Alright guys, welcome back to the channel. My name's Tom, and in tonight's episode we've got something a little bit different. So today is Thursday and I've been invited to go and do a talk tonight in my local pub with a load of the locals to chat about the night sky, constellations, the solar system and what my hobby is. And I am super nervous. I didn't even realise I was going to be so nervous. So a few weeks back my neighbour knocked on my door and he says to me, Tom, I see your observatory roof is off quite often. I would like you to come down to the pub and have a chat with a load of local people. And I'm thinking to myself, yeah, no problem, this will be absolutely fine. I wake up this morning and oh my God, I am cacking myself. I'm thinking, damn it, I'm actually going off to talk about astrophotography and astronomy and the solar system. And I've only been doing this for a short period of time, so, you know, there's nothing like throwing yourself in at the deep end. I'm not one for backing out of stuff, so I'm just going to go for it. What I did, though, I sort of prepared myself in a way where, I've been looking up certain things and the solar system and just sort of the different planets and the gas giants and the ice giants and stuff like that. And then what I decided was I want to be able to give people something that they can take away and they can actually have a little bit of a practice. So I actually printed out a load of the star charts and actually made all of these up. I cut them on my CAD machine over in my factory. So yeah, I came out with this and it just makes it a lot easier. If you're going to identify anything in the night sky, you can just set the date on it. I put a couple of pins in so people can actually have a look and identify all the different constellations. And then on top of that, I thought to myself, well, you know, when I want to look at constellations in the night sky, I kind of want to do it when it's the new moon, so that it's as dark as possible, visibility is better than any other time. So I came up with a moon phases calendar as well. So this one I actually left for the kids because I thought to myself, you know, it's a nice little thing. It's a school holidays at the moment, and what you can do is you actually cut out all of the back sections and you stick it all together, and that's how you can create your calendar. So lots of instructions on there for the youngsters or the adults, it doesn't really matter, and hopefully that's going to go down well. So yeah, I'm gonna sort of sharpen up on a couple of different things that I kind of feel like I completely forgot about, and then what I'll do is I'll show you some of the clips that I've done for this evening. Guys, also remember, subscribe, like and throw me a comment below and I'll come back to you. I haven't commented on last week's video just because I've been preparing for this this whole talk thing, and I'm kind of taking it a bit serious, if you like, just because for me, learning about astrophotography was what I wanted to get more and more people into. So hopefully tonight's going to be the night where I actually might be able to get some interest into the community about astrophotography and about turning their lights off at night and keeping the light pollution down. So let's get into this.
Tom is our local astronomer, and it's very kind of him. We're very pleased to have him with us tonight. It's very kind of him to come and talk to us about what we might see around this time of year, especially if we looked up in the sky above Great Oakley. And I guess we all look up there, we look up and see those stars twinkling and we think, well, that's interesting. I wonder what the hell it is. I wonder where it is. Has it got a name? Well, tonight we might find out. So, introduce no more ado, introduce you to Tom Wakeling, my next door neighbour.
Thank you, Martin. Appreciate the introduction. So, hello everybody from the Maybush. So, yeah, like Martin says, I'm an amateur astronomer. I've got a small following on YouTube, and I've got a Facebook page. And what I do is I am actually an astrophotographer. So I take photographs of the night sky with my telescopes. So I've got a collection of telescopes that I use. I brought some along today, which I'll go through later on this evening. This is a photograph that I took myself with this smart telescope. So this is for solar, observing lunar and galaxies. So you can see the sunspots that we actually picked up on the sun, which is why I took this photograph on this specific day. which was just before the solar eclipse, which travelled across America at the time. We could have seen the solar eclipse slightly. The sunspots are cooler areas and they change daily. The temperatures of the sunspots are around 10,000 degrees Fahrenheit. So pretty hot, you know, you wouldn't want to go there. As we move closer to the core, it reaches an incredible 27 million degrees Fahrenheit. So super hot, which is why we get lovely summers where we can sunbathe and, you know, sit on our loungers in Spain and have a bit of fun. It would take over 330,000 Earths to match the mass of the sun and 1.3 million Earths to fill its volume. So a lot of Earths can fit inside of the sun. So it's huge, and you don't really appreciate actually how big the sun is. This telescope, although it's a great telescope, is very much for beginner astronomers. So if you wanted to get into astrophotography, this is a great scope to use. We're going on to the planets. So there's 8 planets in our solar system. Mercury is the closest to the sun. It's the smallest planet in the solar system, and it has no atmosphere to retain heat, leading to extreme temperatures from minus 280 Fahrenheit to 800 degrees Fahrenheit. So yeah, really cold and really hot. So yeah, again, it's great for a nice suntan, but not very good in the winter. It resembles our moon in so many ways. Moving on, we've got Venus, which is similar in size and structure to Earth, but it's got a thick toxic atmosphere. So the surface temperatures are 867 degrees Fahrenheit. It's hot enough to melt lead due to a runaway greenhouse effect. So this means its greenhouse gas is sufficient to block the thermal radiation, preventing the planet from cooling and having liquid water on its surface. Planet Earth, which we all love, don't we? So Earth is the only planet known to support life. It's a diverse climate system and abundant liquid water. Earth is 93 million miles away from the sun, and it's home to the human race and the Maybush Inn. And then we go to Mars. It's known as the red planet due to the iron oxide and its surface. It doesn't mean it's nice and sunny there all the time. It's actually a pretty miserable place. But it's the closest that we've got to Earth. Features the tallest volcano and the deepest canyon in the solar system. The temperatures range from 70 to minus 220 degrees Fahrenheit. So it's not that nice to go there really. So everyone's talking about, let's go and live on Mars, let's stay on Earth, it's much nicer. And then Jupiter, so it's the largest planet in the solar system. It has a great red spot and a giant storm larger than Earth with raging winds of up to 425 miles an hour. It possesses a strong magnetic field and numerous moons, including, I always get these names wrong every time I talk about them. So it's Ganymede. It's the largest moon in the solar system, and it has a total of 95 moons around Jupiter. So when you look at Jupiter, you can see some of the moons through an eyepiece, but you don't actually see all of the moons. And then we've got Saturn, which is known for its extensive ring system composed of ice and rock particles. It has a large number of moons, totaling 146, including Titan, which has a thick atmosphere and liquid methane lakes, and it's larger than Mercury itself. If you went to stand on Saturn, what you would do is you would fall through all of the liquid for miles and miles until the pressure was great enough to crush you. So you don't want to go there either. Right, no funny jokes. Uranus.
Shut up, friend.
It's one of the 2 ice giants. It's more than 80% of the planet's mass is made up of hot, dense fluid, methane water, ammonia above a small rocky core that heats up to 9,000 degrees Fahrenheit, even though it's so far away in the solar system. It has a unique sideways rotation rolling around the sun on its side. Its blue and green is due to the methane in the atmosphere. So again, pretty smelly. And then we go on to the last planet, which is Neptune. It's the last ice giant. It's known for its intense blue colour and strong winds, the fastest in the solar system. It's a large storm known as the Great Dark Spot. Neptune has 16 known moons. Neptune is nearly 3 billion miles from the sun. So when you look at that through a telescope, you literally see a dot. And then we do have another planet in our solar system, don't we? But in 2006, they actually downgraded it to a dwarf planet, which is Pluto. Then we've got the Milky Way, and that's our galaxy. Yeah, so when you see the Milky Way, the reason why we call it the Milky Way is because it's milky. So it's believed that in our galaxy alone, we estimate there to be 100 billion stars. So it goes to show you how big space really is, because this is just our galaxy. astronomers think that nearly every star in the universe has at least one planet, but most likely several. So when you look at that, you think, wow, that's a huge amount of planets just in our galaxy alone that we've not really explored. And then we've got the universe. There are at least 2 trillion galaxies in the visible universe, which we could contain well over a septillion stars. That's the number 1 followed by 24 zeros. I wasn't going to put down 24 zeros. I mean, it's just ridiculous, isn't it? So these galaxies are all shapes and sizes. I actually looked this one up, how to pronounce it, and I forgot.
Come on, Tom.
Alcyonus, I believe. And it is 16.3 million light years in length. Yeah, so travelling at the speed of light, it would take you 16.3 million years to get there. So, yeah, I think we'd be dusty by then. And my passion is not just astronomy, it's astrophotography. So like I say, I like taking photographs of the night sky. This is my observatory. It's just a shed, but it's a shed with a roof that comes off, and it's my shed, and I love it. So...
Man cave.
It is a man cave, yeah, absolutely. I haven't taken photographs of the other side because it's just a complete mess. But in this side is actually my warm room. And that's where my computers are set up so that I can actually remote access my telescope from in that room. And then this is my big telescope. So I couldn't bring my big telescope tonight because it's just too heavy, it's too big, and it wouldn't actually fit in here. Yeah, well, this is a Celestron C11. So there's all sorts of telescopes that you get. Celestron range from 4-inch telescopes to 14-inch telescopes. I didn't quite get the 14-inch telescope because you're talking about £14,000. It's a lot of money, and I thought, I can't tell my wife that I've spent £14,000 on a telescope.
So how big is that one, Tom?
So this is an 11-inch. So this is the C11 Cassegrain-Schmidt telescope. Yeah. So what we have in this telescope is we have a primary mirror at the bottom of the telescope, which is just a huge mirror. And then in the top, we have a tiny little mirror. So what happens is the light comes through, hits the main primary mirror, bounces back, hits the secondary mirror, and then bounces forward into where you would see an eyepiece. So I brought an eyepiece along with me, just so that you could see this is what would actually go into the back of the telescope, and you would look through as an observer. So because I'm an astrophotographer, I have to track the night sky. So if I choose a target, I need to make sure that when I'm photographing it, I photograph for hours and hours, and sometimes days, sometimes weeks. It depends on what target I'm actually going to be photographing. So on here we've got, this is called a StarSense Auto Guider. And what that does is that actually reads where my telescope is on Earth, and then it tells my telescope where it needs to move to, so that it can actually get the right images that I'm going to be photographing. But it's also a little bit smarter than that because it also guides. On this telescope here, we've got a little camera. That's a guiding camera, so that will literally, it will take a photograph of a star and it will actually track that star. It will make small adjustments to the side rail on the telescope to make sure that it actually follows that star, and it will keep it in frame the whole time. So the less movement, the better your images come out. This is called an Eagle 5S Plus. It's just a computer, really. What that does is that means that I can remotely access my telescope from anywhere in the world. So if I go to holiday in Australia, all I need to do is phone up my mum and say, can you just remove the roof for me? And then I can deal with the rest, and I can turn my telescope on and actually start imaging from the other side of the world. When you get a big telescope, and this has a focal length of 2,800 millimeters, so it goes really quite close in detail to all of these stars and these planets and nebulae. If you just touched it slightly, it would rock the whole image. And when you're trying to focus your actual images, it's very difficult to do that if you just slightly touch it. So I tend to not to touch it, so I actually have a motor that does that for me. We've got something a little bit special on this telescope. So there's 2 types of the Celestron telescope. They brought out a telescope called the Rasa telescope, which is a telescope that's not for observing. It's just for astrophotography. But I wanted to be able to do both. I wanted to be able to invite my nephew around and say, you know, come and have a look at the planets and stuff. It's great fun for the kids and for the adults, you know. So I brought the Celestron C11. decided against the Rasa. However, what I did buy was I bought a Hyperstar, and that's this piece here. So what happens is when I told you just then about the secondary mirror, it's the small mirror in the top of the telescope. So the light goes through the corrector plate, hits the primary mirror, hits a secondary mirror, bounces back into the camera. Well, this time it's a little bit different. So I actually took the secondary mirror out. I put a Hyperstar on instead, which is a load of different lenses. And those lenses correct the light that comes through. It hits the primary mirror, and then it comes through the Hyperstar, and it turns it from an f10. So I'm not sure if anyone knows about photography, but the F number means that more light gathering. So the higher the F number, the lower the light gathering. The lower the F number, the higher the light gathering. So this is actually a Hyperstar V4, and it takes my Celestron telescope from an f10 to an f1.9, which means that it's 25 times faster. So if I take a photograph for a minute, that would, if I had my camera on the back, take 25 minutes to actually gain the same amount of data, which is why I got the Hyperstar. And then we have a dedicated camera on the back as well. So when I told my wife that I was going to go and buy a new camera, and she says, "Are we going to be able to take that on holiday?" And so this is a German equatorial mount. Yeah, so what this does is it locks on to the North Star, so Polaris. So how that works is Polaris is a set position, so that's always in the same place. So my telescope is always lined up to that, and it'll rotate around. And the equatorial mount is great for astrophotography. Moving on, here are some of my favourite images I've taken with the C11. So my first image is, does anybody know what this one is? Orion's Nebula. Yeah, everyone's heard of Orion?
Orion's belt?
Yeah, you've heard of Orion's belt. Well, this is an Orion's belt, so this is Orion's Nebula. It's one of the biggest and closest nebulae to us on Earth.
It's a photo you've taken as well?
Yeah, I've taken this photograph, yeah. And so this is actually Orion's Nebula, and this one is called the Running Man. So I actually, because of the Hyperstar, it takes my telescope, which is a 2,800mm focal length, which, like I say, it's super zoom. It goes so close to everything, but it turns that into a 540mm focal length. So what I'm doing is I'm actually losing focal length, but I'm gaining faster images. So which means that I can collect so much data so much faster. And then my second image here is, this is a globulous cluster. So this is the Great Star Cluster in Hercules. So it's made up of hundreds of thousands of stars, which is why you get this called globulous. But yeah, this image took me, I think, 3 nights to actually photograph. So, you know, a full amount of data to collect on this. And then I stacked all of those images. These were around 2-minute images. So it takes me 2 minutes per image, and I'll run the telescope for around 6 hours per night. So it took quite a long time to actually get to that point, but I was really happy with how the stars came out. Again, the most important part of astrophotography is making sure that your stars are pinpoint in all of the actual frame, so even on the edges. So we usually use field flatteners for that, but I don't have a field flattener for the C11. It doesn't work that way. This is one of my first images that I took with my filters. So I brought some ultra high speed filters, and they are H alpha, O3 and S2. Hydrogen is the main gas that's made up in space, and then we've got sulfur and oxygen. Does anybody have an idea of what this could be called? Just based on this section. It could be an animal, or part of an animal, let's say.
Sorry. Tom, why did you manage to get into this? Do you have anyone that taught you, or
No.
like King's College and stuff, studied astrophysics, or?
No, I was always just a normal worker, and I used to look up in the night sky and enjoy looking at the stars. And I started with a pair of binoculars, believe it or not, and
Cool.
worked my way from there. Does anyone know what it is? Any shape that resembles anything?
I'm thinking of
leg.
returns or something. It's like
This is called the Elephant's Trunk Nebula. Yeah, so this is meant to be the elephant's trunk. And yeah, this is in a constellation called Cepheus, which is in the far north. When you're trying to take photographs of the night sky, really what you want to do is take photographs directly above you, because it's less distance, there's less atmospheric pressure to actually photograph through. Did anyone see the Northern Lights the other day? Or the other week, sorry. Anyone see that? Did you not? A bit crazy, but me and my daughter and her boyfriend went out into the night at 12:30 into the back fields, and we took a photograph of the Northern Lights, which you don't often see the Northern Lights down south. And it was one on my bucket list. And I said I always wanted to see the Northern Lights. The kids loved it. They had loads of fun out in the field. And then that was just at the back of the field. Interesting evening, you know, because you don't see things like this in the south. It's very rare. So it is one off of my bucket list. But then saying that, it's kind of not, because my bucket list was to go and see the Northern Lights up north. So, you know, not the Northern Lights down south. It's not just like taking a photograph of somebody and saying that's what they look like. It's taking a photograph of an object and deciding on what colour palette is best to use on that image. So you could look at 1,000 different elephant trunk nebula from all different astronomers, and they would all be different. So the colours would all be different. Everybody has a different eye for it. I like to try and go with as natural as possible, so I use the RGB colours, and then what I do is I line them all over the top of each other, and that's how I get my images. And then this one is one I actually took last week. So this is the question mark nebula. And I didn't actually quite get the full question mark because it's such a huge nebulosity, but I did get the nice detail within inside the actual gas cloud itself. And this is how stars are actually born, is with all the gas clouds and particles and rocks, they clump together and you get new stars. This one, does anybody know what that could resemble? A sombrero, maybe? It is called the Sombrero Galaxy. And then this one is our closest galaxy. So this is Andromeda. On a clear night, you'll actually be able to see that as a smudge in the night sky. So you will actually be able to see that without binoculars, or, you know, just visually you'll be able to see it. And then this one is called Markaran's Chain. So this is actually a group of galaxies. So, you know, like I said, our galaxy's got, you know, 100 billion stars. If you talk about Markaran's Chain and you talk about how many galaxies, this is just such a small fraction of our night sky that we photographed. And this is only a small section of it. When we go onto the system, you'll actually be able to see that there's hundreds and hundreds of thousands of these galaxies all dotted in the same area. So even if I'd have moved the telescope slightly down, you would have just seen so many galaxies everywhere. Okay. All right, so everyone's got a pack with your star chart and your moon phases. So with the moon phases, you might want to build it. I built one, and I weren't going to build 30 more of them. If you're going to look out in the night sky, what you want to look out for is the new moon, which is no moon in the sky. So it takes 27 days for the moon to actually rotate around Earth, but it's 29 days from new moon to new moon. I use a software called Stellarium, and this is how I plan out my evenings of taking photographs in the night sky. So at the moment, if we was to look north, so on today's date on the star wheel, let's say we're at 8 PM, aren't we, on the 30th, and we was to look north, Cepheus is going to be just below. So this will be Polaris up here. So just below that, and here we go. So when you do your star chart, you'll actually see that Cepheus is just below on the right of Polaris, the North Star, so which is here.
Are we looking north?
Yeah, so if you was to look north, yeah. So Polaris, although it's not actually that bright in the sky, you'll always be able to see it. You can download an app. So Stellarium you can download on your mobile phone as well. And it's really great because it will show you where exactly everything is with a compass. So you don't necessarily need this, but it is quite handy to have. We've got Cepheus, which is where we took a photograph of the Elephant Trunk Nebula and also the Iris Nebula. So here's the Iris Nebula. which I took with the 2800mm focal length. And this shows me all of my targets that I can actually choose in the night sky. So underneath of here, this is the Ghost Nebula. And you can see that they look like little ghosts. I haven't taken a photograph of that one yet, so if I ever get invited back, maybe I'll take a photograph for that occasion. Ursa Minor, which I'm sure everybody knows about. We've got Ursa Major, and they're the bears. So you've got Ursa Minor, which is the small bear, and Ursa Major, which is the large bear. And if we actually turn this section on, you'll actually be able to see all of the different ones. And that's pretty much how the star charts work. So you pick your date, and you'll actually look north, you'll look south. So you've got it all different directions. So if you can only look east or west, you just turn your star chart so facing east. Some of the constellations are easier to find than other constellations. Some of them are really tricky to find because the stars are not very bright. But others, like, you know, Ursa Major, which is also known as the Big Dipper or the Plough, it's really easy to find in the night sky. And that will change all different times of the year. So with this, what I love about this software is that we can actually progress through the whole year if we'd like to, and we can see exactly what's happening. So as you can see, the North Star is in its fixed position, and that's how it rotates. These charts are really good. They're great for if you've got your grandkids round or you've got your kids round and you want to go into the night sky and just have a little look at what's around. Really simple to use. Like I say, you want to go out on the new moon if you want to look at all of the stars really clearly. And you need to about 10 minutes for your eyes to adjust so you can actually see everything in the night sky properly. We're actually quite fortunate. So we actually live in a Bortle-free area. So although it will come up on the calendar as a Bortle 4/free area, which means that we get really dark skies. You know, if you're from the village and you look out into your garden towards Harwich or Clacton or even Colchester, you'll see the glow from those towns. So we're really lucky that we live in such a lovely area where we do get dark skies and we can take advantage of those. So like I say, if you're going to look at the night sky, you're best off looking sort of directly above you. If you want to get a sun lounger, it's the best way to actually look at the night sky. My wife often comes out and says, "What are you doing laying in the garden? It's 1 o'clock in the morning." And I say, "Well, I'm just looking at the sky, you know." But when you're standing there, you know, yeah, or
And ladies and gentlemen, I've seen it.
Without really getting into boring detail and make you all fall asleep. And I see none of you have brought pillows today, so we kind of won't go into any more into the night sky. But like I say, you've got your calendar. This is called Stellarium. It's a free software. Please download it. It's well worth it on your mobile phones. It's so easy to use. I've got it on my mobile, and it's just a click of a button, and you can literally look around wherever you would like to. You can change the time down the bottom, and you can see what's going to happen through whatever time of the night. So at 4:55 in the morning, it'd probably actually be getting light, but the Milky Way would be right above us.
4.7 stars it gets, 176,000 reviews.
There you go. Yeah.
I've nearly got it.
Yeah. So like I say, it's completely free and it's great fun to use. Even if you're just sitting in your front room, you know, I'm a typical man. I sit there and I don't like watching some of my wife's programs. So I'll sit there and I'll look through at stars instead. This is my travel scope. So if we go on holiday, my wife hates it, but I stick this in the car and she says to me, "Really, do you have to take the telescope?" So we're going to Centre Parks on the 20th of June. And she said, "We're just going on holiday though, aren't we? You're not going to do YouTube videos." And I've already been thinking, how can I get it in my car without her finding it? So this is a great little telescope. It's got a different kind of focusing wheel. And then we've got a field flattener on this as well. So this is very different to the Cassegrain-Schmidt telescope. This is an APO or APO doublet telescope. So this doesn't use mirrors. This uses lens to correct the actual light that comes through. And that's how you get your focus. And then this is a little computer that I have on the side of it. So again, this telescope I can leave anywhere and I can run this anywhere I like in the country or around the world. What they've done these days is they've brought out all this new technology with AI and all different sort of systems. and they came out with this, which is called a C-Star. So it's an S50 telescope. And what you do is you set this up with your mobile phone, and you can actually take photographs of it, of anything that you would like. It will track everything for you. So it does exactly the same as this, but at a fraction of the price. So this setup here is about £5,000. This is £500. So there's a huge difference, but the quality of images that you get from this is actually really quite phenomenal. And that's pretty much it, guys. Like I say, I'd like to thank everyone for, you know, listening to me and taking the time to come out. So, thank you.
We noticed earlier on that you said that you might be inviting back. I think that'd be brilliant to invite Tom back. In a
You know, don't be afraid to go out into the field at, you know, 12:30, 1 o'clock in the morning. You know, you've got to go and have a bit of fun, haven't you? I did say to the kids, be quiet, it's late. Sorry, before everyone leaves or gets a few drinks, I've taken some images that I got printed out, and if you'd like to take them and frame them, you feel welcome to. I got all, I'm not sure how many of each I got. The question mark nebula, we got the sombrero, which I know some of you didn't think looked like a sombrero, but look now. So yeah, guys, help yourself to those. If you just want to, I mean, even to show your grandchildren or your children. So guys, thanks for watching the channel. It's been an experience and a half going off and doing this talk last night. So super nervous yesterday about doing this talk, but actually when I got there it was really quite nice. I had a couple of beers, it was great company, and it was nice to have a chat with people about the solar system, about the galaxies, and just about the telescope and astrophotography and how much I love it and my passion for that. So I'm looking forward to getting invited back again, where hopefully we should have a little bit of a clearer winter and I'll be able to share some nicer images with everybody. So again, thanks for watching the channel, guys, and I'll show you a couple of the images that I shared last night. Cheers, take care.